Hey everyone, welcome to this session called Protecting Endpoints in a Zero Trust World. My name is Sami Laiho. I'm a senior technical fellow at my own company. I live in Finland. I'm based near Helsinki. I'm a Microsoft MVP in the core operating system since 2011, so about a decade now. I specialize in troubleshooting and security, and I'm here today to talk about Zero Trust security. I normally tour around the world. For the past about 365 days I've been sitting in my basement, where I actually am sitting right now as well. Can't wait to get back on the road, as speaking to the same camera for every day of the week just starts to get me a little bit of cabin fever, and it's really hard to remember if I told the jokes to you already or not. It's really hard to keep up which day it is and which course it is, as it's almost the same content every single week. When it comes to COVID, and of course everyone talks about the pandemic, there is a problem now here in Finland currently as well, and I'm quite sure you heard the same, but the Finnish people are actually quite horrified, because now the government has told us that we have to actually stand 2 meters apart, and that's freaking close. I mean, we're not used to this. We want to stand more than 2 meters apart, and now we're forced to get so close to each other. Anyway, getting to the actual topic itself. When Ignite, the last one that was still in person, happened, I remember I was touring around different sessions, and Microsoft was still very much liking this concept of BYOD. So everything was about light management, everything was about super light autopilot deployment mechanisms, and just barely using an MDM to set some settings, but not that much. And people were complaining about Intune not being able to manage all the settings, but Microsoft was more answering that you don't need to manage all the settings because we're only lightly managing this. Well, I always called this the bring your own disaster model, and I never liked it. Now, the great thing about this is that if you heard the last two Ignites 6 months apart, the last one was just like a week ago, a month ago, and now Microsoft is all about Zero Trust. Full management again, full visibility to what users are doing. So we're moving from a very lightly managed to a very tightly managed environment. And today we're here to look at what this Zero Trust actually means. One thing I hate about Zero Trust sessions that I listen to is that they kind of give Zero Trust a really bad sound to it. Everyone makes Zero Trust sound like it's a bad thing. I mean, it sounds negative. There's zero trust in anyone. We don't trust any of our employees. The IT doesn't trust us at all. It sounds very negative, although we should remember that there's a very good thing that we're trying to achieve with Zero Trust. So Zero Trust is there to make us able to work exactly the same whether we're in the office or in Starbucks. It's supposed to be productive, fast, as easy to use as on-prem in the office before. Yet it's still supposed to be as secure as it was before, only inside of the barriers or the borders of our office spaces. It's supposed to make this digitalization happen faster and better, meaning that we can have anyone sitting in any office, on any seat, on any desk. It's also trying to answer very common ways of attacking an environment, where we actually compromise a single machine and then laterally move around the office, or let's say around the network itself. This fights against things like Mimikatz and other things that can do past the hash attacks. Zero Trust core principles are verify explicitly, always use least privileged access, and always assume breach. We'll talk about these components of Zero Trust that build up, but these are the main core principles of Zero Trust. There used to be a saying that there's only two kinds of companies in the world, those that have been breached and those that don't know they've been breached. And now we're kind of just putting that into effect. I mean, we're really starting to treat everything assuming that we have been breached, there's someone listening, and this is not a secure network. Of course, the middle one here, use least privileged access, is a favorite of mine because my company has been gaining most of our fame and our money from actually getting rid of end user admin rights. So now it's something that is not just for most regular office users, but also for admins, also for devs. And of course, one of the big problems in our networks is phishing, which means that we really want to verify everyone with a strong authentication mechanism in any case, not depending on whether you're in the internal network or if you're in the external network. If we think about one of the biggest things there is in Zero Trust is kind of think of it like moving the border of your network from being around your office building to being around your data center. And just think about how you would build your environment and your configurations if you would treat your office network exactly like internet. Just think of your office building providing a public wireless LAN for your users to connect to, and make them connect exactly like they would from the external network. So don't treat internal networks like you treat external network. I mean, don't treat them different than you would treat an external network. So just make sure that there's no of that old style of let's loosen up the firewall when we're in the internal network. Forget the whole intranet, the whole internal network concept. Just start treating all the networks the same. If you need a VPN to connect from Starbucks, then you would use the same VPN connecting from your office network. The core mantra of Zero Trust is never trust, always verify. And this just means that not depending on any factors, we never ever trust anyone. We always verify what devices are used. We always verify what users are used. We always encrypt the communications. We always encrypt the data. Zero Trust is built up of different components. So the main components, identities, we always verify everyone with strong authentication. Devices, gaining visibility into all the devices that are accessing your networks, making sure that they are compliant, healthy, they have their antiviruses on, they have their firewalls on before you even let them access. And you can identify every device. Applications, meaning discovering shadow IT, making sure that people are not running what they want, but what you want. As we would previously let people use applications that we had not specifically approved, that's not the thing anymore. Now all the applications need to earn their trust before we will allow them. Then there's data. When we used to do more of a perimeter-based data protection, now we're concentrating on the data itself. So it doesn't matter where the data travels, where in our previous lives, data would be encrypted in certain networks, but not in the internal networks, for example. Now, instead of only encrypting the thing around the data, we're actually starting to encrypt the data itself. That doesn't mean that you wouldn't need BitLocker, but instead of only relying on BitLocker and having it travel through normal networks unencrypted, now we will have BitLocker to make sure our computers are still intact and the data cannot be stolen by a physical theft. But on top of that, we will also encrypt the data itself. So things like encrypting file system will reappear after being gone for quite a long time. Infrastructure itself. So we're trying to investigate the things happening in our network. So what we're going to do is we're going to monitor all the connections, even if they're internal connections. We're trying to see if there's risky behavior. We'll try to flag bad-looking ways of using our environment. And we're going to make sure that everyone has only the required access. So we're going to employ the least privileged access. We're also making sure that our admins don't have excessive privileges. So if they only need to manage Exchange or in modern ways the Office 365 components, then they will only be allowed to do that. So we're not having everyone being a global admin. We're not having all of our Active Directory infrastructures admins being domain admins and so on. We'll highly tier all our networks or our infrastructure. And as I already said, we'll encrypt all communication, even internal networks. Everything will be always encrypted. We'll also detect the network so that if someone is connecting through a secured line, we will allow them to have more access to our data and our services. If they're using a web interface only, then they will have less. This means that we will have conditional access policies, potentially microsegmentation of the network, just making sure that things on the network that don't need to talk to each other will not. So one of the core things is forget the internal networks, which means that you're going to have a lot of more VPNs or IPsec, different ways of encrypting and especially authenticating the communication, even if it happens in an internal network. This will actually be our first demo. So let's talk about this a little bit, and I will first draw a little bit about what I'm going to make happen, okay? Just need my pen here. So what I'm going to do is we're going to have a DC here. This will be our domain controller, and then we're going to have a few different laptops here. This is my number one client. What we're going to do is this is going to be our domain network, and then in the same physical network, I will get these enemy computers, unidentified computers connecting to the network. We're going to allow communication to the domain controller because we're going to build IPsec based on Kerberos. And in Kerberos, we have to authenticate first, which means that we will talk to the domain controller, and the domain controller can answer us and provide us with policies and authentication. We'll protect that in other means or by other means. What we will make sure is that although the domain people could talk to the enemies can never ever talk to anyone in our domain. They're in the same virtual network. They're in the same physical network. So there's no firewalls in between. We're just going to purely build an IPsec protected network. And in our case, we're going to use the AH protocol. The AH protocol is the authentication protocol. IPsec is built of two different protocols. So we do have ESP as well, which provides us with the potential encryption. We're not going to do that right now. We're purely going to authenticate all the networks, but we could easily just add encryption if we wanted to. So let's build this in a demo environment. Let me just find my demos here. Let's not update that right now. What I'm going to do is I'm going to build an IPsec group policy here. Nowadays, we are talking about the Windows firewall with advanced security and connection security rules. First, I'm going to build an exemption for our domain controller. This will be 172.16.0.12. And we'll build another rule, and now we're going to build an isolation rule for our whole network. We're going to require authentication for inbound connections, meaning no one can talk to us unless we trust them. And requesting authentication for outbound connections because I still want to be able to get to Google even if Google doesn't want to speak IPsec with me. And we're going to identify both the computers and the users with Kerberos 5. We could do this with certificates as well if we would have things like iPads or Linux or Mac OS X or stuff like that. And this will be all profiles. This will be called isolation. There we go. That's super simple. Let's just GP update this. And then we'll need to GP update these machines as well. This is the enemy, this is the Windows 10 machine. This is our internal computer, I mean, this is our trusted computer, so that's the domain computer, and then this one here will be our enemy. To make this a little bit more fun, I'm actually going to make it so that this will be trusted first. So what I'm going to do is I'll just show you ping CDC1, that's our domain controller, that just pings 1 millisecond or less, okay? Then I'm going to ping our student 25.2, and you can see that it takes a little bit overhead on the first packet because we have to do authentication, but there's no overhead after that. So many people have the instantly when I start talking about IPsec. I've been teaching and deploying IPsec since year 2000, which is 21 years ago. And people always assume when I say IPsec that we're talking about VPNs and encryptions. In this case, for example, we're not encrypting anything. We're just making sure no one talks to us unless we trust them. Okay, so I'm going to do that, and I'm just going to leave this pinging here. And then what I'll do is I'm actually going to drop this guy out of the domain. And you can see this happening here. I also need my network interfaces. So what I'll do first is I'll just drop this down to a workgroup. Okay, and I won't boot it now. What I'll do is I'll just I have a Kerberos ticket, and I still have an authenticated TCP/IP connection, which means that I could wait and it would just die. But what I'm gonna do is I'm just gonna say disable, and then I'm gonna say enable. Now you can see that the network interface is coming back online, but we can't even talk to this machine anymore. So it's just totally out of bounds when it comes to this computer. If I join it back to the domain, it could talk to this one. There's no like one single port open or only 8 ports open. I mean, there's 65,536 ports, which none of them would be speaking to you unless I trusted you. And now when we have this, then this makes things even cooler, because that means that we can actually start using Windows firewall rules where we can say that, okay, from now on, I will allow, and I'll say a custom rule, and I will allow remote desktop. Well, okay, let's do all programs, any kind of program talking to my TCP port 3389. That's my RDP port. And instead of the old way of saying from this subnet to this subnet it's allowed, from IT management to production it's allowed, stuff like that, instead of that I'll just go forward and say, I don't care where the heck these are, I only allow this if the connection is secure. And then I can say I only will allow it if this connection is coming from our G classroom admins, and only if they're using their computers, which would be, for example, in this case, only from our management computer, which is called student 25. Okay, so now only when that user would be logging on to this computer could they talk to my RDP. Only from privileged access workstations. All right, I have to get this back online, but I'll have to boot this now when I'm joining it back to the domain. Okay, we'll just let that boot. And while that's happening, we can go forward. So known and healthy devices. Well, we have to know that all the devices that are talking to us are of a certain compliance level. That means that we will always say that we only trust devices if they're proven that they are worthy. Well, if we are talking about identifying people, and if we're talking about identifying devices, then you have to remember that the Windows 10 machines that you usually have for enterprise use, they have a TPM chip, and that TPM chip is already one factor, which means that technically if you want to do two-factor authentication, or call it multi-factor authentication if you wish, then that you're already doing that if you're using Windows 10 with a PIN code. That's a common question that I get when people are asking, like, why is the 6-digit PIN code safer than a 16-character password? Well, that's because the PIN code only works on that device, not the next one, as the password would work from anywhere where you can do password authentication with that user. So the PIN code is tied to the TPM chip, which means that the TPM chip is something you own, that's one factor, and the PIN code is something you know, which is the second factor. Same goes for protecting the TPM with your fingerprint or your facial detection. Now, this is something we've hopefully gotten accustomed to using with our cloud services. This means that when you go to your email or you go to your Outlook online, it will ask you for MFA. That's something that you should deploy for everyone. But when we're talking about authenticating to devices, then we can make requirements of the MFA easily on Azure, but what has been a little bit more difficult has been to do that on the actual devices themselves. And what I'm doing here is I'll show you an example of my privileged access workstation, and I'm using Cisco Duo, but you could be using other things that provide MFA as well. Currently, Microsoft doesn't really support what I need from MFA, which is actually using MFA for logging on to the physical device itself. So here I have a computer, and I'm just gonna log off this machine now. I'll show you, this is my privileged access workstation. And here, when I start logging on, I'll use my password to log on. But when I do that, Cisco Duo actually pops up a note on my mobile phone which says login request from Microsoft RDP. And then I'll have to press approve on my mobile phone, which I'm doing right now. And there we go. Okay, super easy. Duo is actually free for up to 10 users. So if you don't have anything else, then you can use that for your most critical admin accounts or stuff like that. It doesn't have all the features, but this one, for example, where you can protect the actual logon to a device, I would heavily recommend this at least whenever you're doing RDP to something and on privileged access workstations. The MFA that Microsoft provides will only work for the next step, which would be to talk to your Azure services. They will later on, of course, allow that, and even today you can use tokens. So you can use keys from Phaeton or YubiKey, and you can have like passwordless logon with those. That was my MFA demo. If we think about the times that we've been living in, many of us probably started our careers back in what we call the Admin Epoch. This slide is actually from a very good friend of mine that we sadly lost very recently. His name is Chris Jackson. Maybe you know him as the App Combat guy. But sadly lost Chris. And this is his slide, and he gave me the permission to use this. So this is we were living in these stone ages, which are called the Admin Epoch, and that's the time when people would install whatever they wanted. Apps would be trusted by default. No one would check them beforehand, and no one would list good apps. You just install whatever you wanted. Then we're trying to move, and have been doing this for the past 15 years or so. We're moving and being in this non-admin epoch. And this means that the end users don't install anything by themselves, but the admins install the software. But still, we didn't have the concept of allow listing, which means that people could do whatever they wanted, and then we would help them installing their software for them with things like SCCM, but we wouldn't list trusted apps. We would only try to reactively detect bad things in the network. So instead of that, we want to do proactive security, which means we're moving to this app control epoch where we list good things instead of trying to list bad things. Principle of least privilege. If you think about the user guide for NT 3.1, the first NT, the user guide back in 1993, it actually says that in Windows there is no security if you're logging on as a local admin. But many devs are testing their software only on or only with admin accounts, which of course is kind of the source of the whole problem. There are a lot of things that don't seem to work without admin rights. So we kind of like somehow have to face this problem, and we have to deal with it if we're going to get rid of the admin rights, because we can never have security hindering usability or hindering productivity especially. The good thing about the no admin approach is that we get better performance because our computers can't write garbage on the disks as much because you're not an admin. We get less tickets. I have multiple customers, some of them with more than 10,000 users, for example, and we got rid of the admin rights in 2018 from a Swiss company, and in 2019 they had 75% less tickets. The problem is that people seem to think that if you don't have admin rights, you can't fix your computer. As in reality, it is so that if you don't have admin rights, you can't break your computer. It's kind of like Microsoft just had this submerged data center. I'm not sure if you heard about it. They had two containers submerged, like, I don't remember if it was 10 meters or 30 meters below the ocean. They submerged two big containers full of servers, and they kept them there for 2 years, and then they took them up. And in that 2-year time, they had to replace 9% less servers than they did for the normal non-submerged containers on the surface. And now people are thinking, why would you have to fix 9% less servers? And people would assume that it's because of the cooling, because it would be submerged in liquid and that would keep it so much cooler, but it had nothing to do with that. When they made their research, the only difference was that they had to replace 9% less servers because people couldn't touch them. We get less reinstallations. If I run my own computer with full admin rights, I used to install Windows over and over again about every 6 months to 12 months, so 1 to 2 times a year. When I got rid of admin rights, that went down so that I only had to install Windows once per 5 years. So that's 5 to 10 times less reinstallations. I like that. I'm lazy. Nowadays, of course, you do build upgrades probably, but still, less reinstallations, more productive users. Of course, less malware. I would dare you to take a look at all the hacking conferences you can find, DEF CON, Black Hat, whatever, and see their demos. And remember that none of those demos are cool if they require admin rights. Because the book says in Windows there is no security if you're running a local admin. We get to be lazier as admins because computers break less. I'm actually super annoyed. My family owns a clothing factory here in Finland. We currently produce mainly facial masks because of the pandemic, but we usually build uniforms for companies. And I want new computers because the new computers have secure boot, they have UEFI, they have SSDs, so I would love to get new devices. My problem is that the freaking devices don't break. I mean, I was just fixing a computer and my cousin was worried that it starts to seem a little slow. And it was installed 11 years ago. So I was kind of like more surprised that it was even alive. But the problem for me is I don't get as many new computers now because there's no need, because these computers just keep working. So it's a little bit annoying sometimes as well, not having admin rights. I would never go back to using admin rights myself. I never log on to my machines using admin rights. So I will only elevate when needed, but I would never ever log on as an admin because I know how much better Windows works without. Here are some numbers. Many people want numbers to back up these claims I have. 2019, there were more Microsoft vulnerabilities than ever before. And removing admin rights would mitigate 77% of all critical Microsoft vulnerabilities. But if you think about how malware gets to run on your machine, you should remember that you always have to protect the thing that loads, the entity that loads the binary into their memory. So, for example, if you have a software executable on your server share, you don't have to whitelist the server or allow list the server, because you have to protect the endpoint, because the endpoint will first load the executable into its own RAM. So there's no use in trying to protect the server. The servers are protected by endpoints, and you protecting the ports, of course, if they're network connected, but when they're network connected. But if you think about what actually executes a malicious payload on your machine, most of it comes through email. That means Outlook, which means Office. And then the second biggest way of getting that is your browser. That means your Chromium nowadays, because it's either Chrome or Edge. So if you look at these numbers, in 2019, 100% of critical vulnerabilities in Internet Explorer would have been mitigated. So no patching required. Think about this, 858 vulnerabilities to patch. Yet you wouldn't have to even patch, but if you were not an admin, there would be no problem with Internet Explorer. Well, hopefully you're not using Internet Explorer anymore. But Microsoft Edge, this is the new Edge. This means Chromium engine as well. And 100% of all critical vulnerabilities in Microsoft Office product. That means your Outlook. Think about that. Reactive security, where you patch things and try to keep up to date and brag to your friends that you're up to date in a month's time from the publishing of those, or 2 weeks, or whatever crazy numbers you get to. Some people might forget to patch and they're better protected than you are. So we have problems with this as well, I'm quite sure. So let's look at a few demos. I'm going to solve this problem of principle of least privilege, let's say. Actually, that's the wrong demo machine. This is the correct demo machine. So we have kind of a similar environment. We have a domain controller and a client, but you could do this with Intune as well. So what I'm going to do is I'm going to use a software from a fellow MVP who is speaking on this conference as well, Jeremy Moskowitz. So Jeremy will probably show you more. I'm not going to go deep into detail with this. I'll show you the basics. And let's take an example here. I would like to manage my devices. The problem is I'm not logged on as an admin, so I can't really update my devices. I can see my devices, but I can't really do much with them. I also would like to change my IP addresses, and if I try to change my IP addresses, I'm prompted for an admin account. So that doesn't work, but would be, in some cases, you have engineers that need to connect their laptops to devices with a cable, and that's actually like you're preventing their work if you don't allow them to do this. Also, your limited users can't install printers. So if you try to do this, you can do it if it's coming from Windows Update, but if it's a local printer and you don't have a driver for it, you're out of luck. You can't remove programs. If you try to use tools like Procmon, that won't work, because Procmon needs admin rights. It installs a driver. Okay, let's fix those. So first of all, least privilege manager. We're just gonna add a new rule here, and we're gonna do an executable. But actually, let's do a control panel policy first. And I'm going to allow my user, without being an admin, he's going to be allowed to use device manager. This will run with elevated privileges. That's it. I am going to create an executable policy, and I will actually just create a rule for a path, and I will just add a folder, and on my machine I can browse, and I'll just go and find it for us. See program files, policy pack. Just find my Should be here. I was actually sure. Here we have, sorry. Just I missed that somehow. Okay, so list privilege manager tools. Okay, and okay. Everything will run from that location. And then I will add one more new executable policy. And I will just simply say that this policy will be running if we have a file that is, I don't know if I have Brockmon here. Let's do Brockmon.exe. Oops, I forgot. Let's just see. Should have it somewhere here. Computer 1C users, so I think I can get from here. Okay, so that'll just hit that one certain executable. Okay, actually, I think we did. I just messed up one thing because I think we already did a path rule. I just forgot I did the path rule there. Let's actually do another one. Let's do a executable policy, but we'll create this based on the publisher rather. So we do a signature. Next, find the reference file. This will be Brockmon 64, and this will be Microsoft. So what I'm going to do is I'm going to say that the certificate has to include the company Microsoft Corporation, and that would be a different rule. Okay, let's go back here. I'll just TP update this. All right, so device management without any tricks works. I am still the same user. I'm not using run as or anything like that. Then network connections, Ethernet properties works, and Brockmon works. Okay. Well, this is something we know the users will want, but at some point they will probably want to do something ad hoc. So they want to do something and we don't know that beforehand, so we can't build a rule for it. So let's just make sure we can deal with that as well. We'll do a new policy here, admin approval policy, which will be enabled, will be shown on the secure desktop, and it can also be approved over the shoulder by an admin. We'll need a secret key, so we're just going to generate a random password here. Just copy that to my clipboard. Okay. Then what we have here is GP update first. And now, when I want to, let's say, well, actually we could run Process Explorer because it's actually signed by Microsoft. so that would not be a perfect example, but let's just use that anyway. I can actually go and just remove I have one signature here that I actually kind of messed up with this. So let's just delete that from there and do that one more time. So that we have Brockmon running, but not Process Explorer. All right. So now, if I'll right-click Process Explorer and say Run as admin, then that would require me to do that. But what if I'll do right-click and Run with Policy Pack? Then we have a different thing here. So it gives me a request code. I can call my service desk, and my service desk, I'll just type in the one I had on the policy, and then I'll just protect this with a password so that from now on I don't have to remember that password or that secret key anymore. Yes, please. And then the request code. So let's see here. Let's see if we can copy paste this. And this one says a little bit of information about what we just had. And then we're going to copy that response code and just type that in here and hit OK. And now we can run Process Explorer with elevated privileges once. Now the thing here is, the greatness of this is that we don't have the problem where we would have two user accounts, because when you have a normal account and an admin account, then when you launch something as admin and you save something in my documents, it's the admin's documents, not your documents. So we have this thing we call the dual identity problem. And here you can see we have this elevated here. So I, as a limited user, I am not elevated here. But if you look at my Process Explorer running, it actually is still me, demo user, but I have more privileges. So if you look at this with Process Explorer, now that we have it running, you can see even more here. Go for properties, and you can see that I'm actually part of the administrators group when I run ProCXP64. But if I run like Explorer, for example, I am not part of the administrators group. So we forget the standard Windows way of saying that admin rights are given to users, or per computer, we're starting to give admin rights to processes or tasks. If we have a person here who needs to do this, and we're in a, like I use this in our factory where we have the manager on duty, the manager on duty can also come here and say approve with alternate admin credentials. And I can actually say that I want to allow this. This will allow now it to run. But if you look at Process Explorer and the token of it, you can see it's still me. I'm an admin, still me. So where we used the manager's user account and password, that was only used to provide the authorization to elevate to admin. And with these tools, we can do, I believe, everything needed for actually getting rid of end user admin rights. I've taken away admin rights from hundreds and hundreds of devs as well. So don't let that fool you that people say you can't get admin rights out of devs, but you can. All right. So the last thing on the list here about when it comes to demos is allow listing. So one of the core principles of ZeroTrust is that the applications need to earn their trust before they're launched, which means that we use allow listing instead of trying to fight against 1 million new pieces of malware variants that are found per day, which makes antivirus useless because you can't keep adding 1 million lines to your blacklist every day. That's reactive protection. That's supposed to be done by your antivirus. What we're going to move to is proactive security, which means allow listing. And in allow listing, we list the trusted apps. Hopefully maybe one addition per month instead of 1 million additions per day. So if you don't want to be like this, but rather be like this, you should look at things like Microsoft App Locker or Policy Pack. Policy Pack can do a better job because it can allow you to, when you launch an app, we can say block it, or allow it elevated. As with App Locker, we can only do like deny or allow. But on the other hand, App Locker is in box. So I don't have a single week this year that I wouldn't be doing a whitelisting, or sorry, it's supposed to be called allow listing nowadays. There's not a single week in my calendar that I'm not doing an allow listing project. If you want to do an allow listing project, send me an email. I can send you a quote and I can help you get that sorted out. Like the admin stuff as well, I am for hire. Here is a simple version of App Locker that kills 950,000 pieces of malware per day with no anti-malware even installed. I mean, It just says that you can run everything from program files and everything from Windows folders. If you're an admin, you can run whatever, but anyway, there's no security in Windows if you are an admin, so that's why it's there. And we'll just allow you to run anything from program files in Windows, and because you're not an admin, you can't put things there. There are certain things that we need to have exceptions for because there are known weaknesses to AppLocker, like you can see in Sergey's session on this same conference, but I mean, we can make it secure as well. So the top one there on the list says that we will allow anything that's signed by anyone. Well, that doesn't mean that it just needs to be signed. That means that it needs to be signed by a trusted CA. So you can't self-sign stuff. I mean, you have to have a real certificate to do that. That's trusted by your computer. Am I exaggerating when I say it kills 950,000 pieces of malware per day? No, I'm actually underestimating it heavily. I'm just being safe here. I mean, in all honesty, only 5% of malware per day is signed, which would give you the number of out of 1 million pieces of malware per day, 5% is signed, which means you would kill 950,000 pieces of malware at a minimum per day, but actually you kill way more because this means that they have to be signed by a trusted CA. And for you to get malware that's signed by a trusted CA, then we're talking like Stuxnet level things. So anyway, that should not happen more than a few times a year. So you should be blocking almost everything. I'm not going to have a separate demo on this, but I am going to give you a peek of what my whitelist looks like, or my allow list looks like. And my allow list looks like this. I've been doing allow listing since 2001, and it still fits on one page. As many people think that having a allow listing solution makes you work a lot more. Like I went to Norway for a customer, and we started a project like this, and the first thing they asked me when we got into the meeting room was that, Sami, now that you're here, can you verify one thing? We decided that we're going to hire 2 new people to take care of our allow listing solution. And I said, like, no, I don't agree. Maybe you should fire a few. I mean, when you get this, you save so much time in reactive work where you have to fix computers that got malware or ransomware on it, that this will pay back, and this will make you work way less than you did before. So that's a big mistake. I did the whitelisting or allow listing for our capital, and we started with the list that was 8,000 lines long, and when I was done with the project, we were down to 72 lines. So trust me, you can do this in very, very different ways, very correct ways and very incorrect ways, if you ask me. Of course, everything that we've been talking about needs to be monitored. So one of the core principles of ZeroTrust is you have to be able to have a CM that you keep tabs on even when things are running normally. That's actually a picture of Sentinel, but some sort of a solution that can monitor constantly on what's happening in the network and what kind of events you're having. And they vary in price, they vary in color. Splunk and Sentinel, quite expensive. Greylog is free for up to like 5 gigs of data per day or something like that. And I mean, there's so many different solutions out there. You can use Windows' own event forwarding if you want to, but somehow you have to keep an eye on what's happening in the network. Hopefully it's cloud-based so that it will work the same whether you have the connection, VPN connections on or not, stuff like that to think about. This is my office where I'm sitting now, I wish. This is a slide here just to remind you that you should think about having a security operations center, SOC. It doesn't have to be like this, but you will need one. Maybe it's just you with your big monitors next to you, but somehow someone needs to keep an eye on your environment. One thing I would like to remind you of everything we've spoken about. I think the most important role in security is that in security, don't let perfect be the enemy of good. If you can't easily get admin rights out of everyone, get them out from everyone you can. If you can't make MFA work everywhere, make it work wherever you can. I mean, There are so many times when a security division shoots down administrators' ideas because they find a potential hole in that system. Like I had a Norwegian customer that wouldn't use BitLocker. Now they don't have, currently they don't have device encryption at all because they can't use BitLocker because there's a potential bug in BitLocker. There's no way to actually hack the TPM chip. And that's true. And to hack it, you need physical access to the machine and you need an electron microscope. So atom by atom, you can alter the content of the TPM chip. I don't know about your neck of the woods, but at least here in Finland, those electron microscopes are not really carry-on size. So now you could get 99.9999999% of security, but because there's a known problem, you end up with 0% of security. I hate it. If you think your app locker is not perfect or your whitelist allow listing solution is not perfect, make it as perfect as you can. Still better. Like a very smart Finnish guy called Mikko Hyppönen, the Chief Research Officer of F-Secure, he said, he was speaking at my birthday party, and he said that you don't have to make your security perfect, you just have to make it better than your neighbors. So targeted attacks are, of course, a different thing, but most of the attacks are not targeted, but random. And to protect against those, just make sure that you look less tempting than your neighbor does. If you have any questions, find me on Twitter. I post a lot on Twitter. That's my most active platform. So at Sami Laiho on Twitter. You can send me email at any time at sami@adminepoch.com. If you're interested in more stuff like this, there's a free code, a free trial code for my video on demand library that has everything I have produced online. And if you need a Pluralsight code, I got the 11 Pluralsight courses that I'm more than happy to give you a code for. So just send me an email, I'll get you the code. If you need help with any kind of deployments, whether it's allow listing, getting rid of admin rights, I do a lot of security audits for companies around the world that have been very, very successful and liked. Just contact me with any needs. But with this, I'd like to thank you for listening, and I hope to see you somewhere else and hopefully in person after some time. Make sure to check out Tech Mentor conferences where me and Dave are the co-chairs. So maybe I'll see you in Orlando. With that, thank you and bye.